Okay, so you are going to be taking notes on a new topic called ratios. I know it doesn't really look like it's pronounced, but it is pronounced ratios. So first, let's talk about what a ratio is. So the definition of a ratio is that it is a comparison between two quantities. And quantities is just another word for amounts. So you're just comparing an amount of something to an amount of something else. So here we have a picture that is an example of a ratio where we're comparing these globes to these maps. And both of those things are what we would call navigational items because they help you navigate. And so if you were to count all of them, there's a total of 10 navigational items. Out of those 10 navigational items, 6 of them are globes and 4 of them are paper maps. So if we're comparing those two quantities, 6 globes and 4 paper maps, that's a ratio. For every 4 paper maps, there are 6 globes. Okay, so a ratio can be expressed 3 different ways. And we're going to use this same ratio of paper maps to globes. And so one way to write a ratio is with the word to. So we could say 4 to 6. So if you put the word to in between the two numbers, that's one way to write a ratio. Another way to write a ratio is with this symbol here, which is called a colon. So you can put 4:6, and you say it exactly the same way though. You would still say that 4 to 6. And then the last way to write a ratio is it looks like a fraction, but you would actually again say it the exact same way, 4 to 6. So all of these say the same thing, 4 to 6, 4 to 6, 4 to 6, even though they look different. Over here to the side, it says important. And if you want to put maybe some stars by that, it says fractions and ratios are not the same. So they might look similar, but here's the difference. A fraction is always a part of a whole. The part is the top number, the whole is the bottom number. And ratios can be actually 3 different things. So a ratio can be part to part, part to whole, or whole to part. So the fraction is always a part out of a whole, and the ratio has the 3 different options. So let's look specifically at these 3 different options for ratios. And down here we have part to part. So the one we were talking about earlier, which was maps to globes. That's a part to part relationship because part of the things are maps and part of the things are globes. Neither one of those are the total, which is another word for whole. And so they're both parts. We're comparing part of the navigational items to the other part of the navigational items. Another option is part to whole. So we could look at how many maps to how many total items. So we have 4 maps and we have 10 total items. So that's 4 to 10, 4 of maps, which are part of the navigational items, to 10 total, which is the whole thing. Globes to total would be another part to whole relationship. And then whole to part is just the opposite of that. So we could look at how many total items to how many globes. Or we could do total to maps, either way. But let's look at total to globes. So there are 10 total items and there are 6 globes. So that is a whole to part relationship. Okay, so another important thing here, and I'm going to write this in all caps because it is probably the biggest mistake that people make in ratios is getting them backwards. So order matters in ratios. For example, if we have 2 to 3 and we have 3 to 2, some people think those are the same, but they are not the same. So for instance, maps to globes would be 4 to 6. Globes to maps would be 6 to 4. Those are not the same ratio. They're in a different order. So you really have to pay attention in ratio problems to the order that the problem is talking about. And then we talked about how fractions and ratios are different, but one thing that's the same is because you can write a ratio like a fraction, you can also simplify it. So we're going to look at simplifying some ratios. To simplify a ratio, the first thing you do is that you write it like a fraction if it's not already written like a fraction. So on this one, I'm going to write 5 to 15, but I'm going to write it like a fraction. And then once it looks like a fraction, you simplify it just like a fraction. So you see what they're both divisible by. In this case, they're both divisible by 5. And then you go ahead and divide. 5 goes into 5 one time, and 5 goes into 15 3 times. So that is equivalent to the ratio 1 to 3. So 5 to 15 and 1 to 3 are equivalent ratios. Just like you can have equivalent fractions, you can have equivalent ratios. Okay, so 4 to 12. Again, I write it like a fraction. It's not a fraction, but you can write it like a fraction. See what you can divide by. They're both even, so I could divide by 2, but I can also divide by 4. So I'm going to go ahead and do that. 4 goes into 4 one time. 4 goes into 12 3 times. So this one is also equivalent to the ratio 1 to 3. So therefore, 1 to 3, 5 to 15, and 4 to 12 are all equivalent ratios. The next one is 24 to 16. I write it like a fraction. I see what I can divide by. This one I can divide by 2. I could also divide by 4, but I see that they're both multiples of 8. So I'm going to go ahead and divide by 8. 8 goes into 24 3 times, and 8 goes into 16 2 times. A lot of people get to this point and they go, oh, it's improper. If these were fractions, then yes, that would be improper. But there's no such thing as an improper ratio. So this is how you keep it. 3 to 2. Again, you don't want to mess with it because you might mess up the order. Okay, and then just like the globes and the maps, we have one that is in picture form. So we have 6 hearts and 2 moons. So that's the ratio 6 to 2. And I can simplify this by 2, and I get 3 to 1. We can compare that to the first 2 we did where we got 1 to 3. Remember, 1 to 3 and 3 to 1 are not the same thing. So that one's not equivalent to those first 2 we did, but the first 2 are equivalent to each other. Okay, so that's the ratio notes. Make sure you have all of that written. You may want to pause the video if you're not done. But we're going to go ahead and look at some ratio practice problems. The first one says, at a bakery, for every 5 cupcakes. Let's see, for every 5, Okay, there we go. For every 5 cupcakes, there were 8 cookies sold. Represent the ratio of cupcakes to cookies by 3 different representations. So first thing to do here is to write out the order that they asked. because they could have said cupcakes to cookies. They could have said cookies to cupcakes. They could have said cupcakes to total. There's lots of different options. So we're going to go ahead and write out, they wanted cupcakes to cookies. I usually use just the letter, but they both start with C. So we'll just write it out. Cupcakes to cookies. And then we look and see how many cupcakes were there. There were 5 cupcakes. There were 8 cookies. So we can't even simplify that. They didn't ask us to anyway, but that is our ratio. They did ask for 3 different representations though. So that was one of them. We can also write it with the colon, or we can write it with the word 2. Okay, question number 2 says there are 28 girls to 32 boys. Okay, so 28 girls, 32 boys. What is the ratio of boys to total? No, sorry, boys to girls. Boys to girls. Boys to girls. So on this problem, a lot of people would accidentally do girls to boys because that's the order that is in the problem, but it specifically said boys to girls, so you have to put it in that order. 32 boys, 28 girls. We could stop there, but it also said, it didn't say to simplify, but we can simplify, so I do want to show you that really quick. So a number that goes into both of those is 4. 4 goes into 32 8 times, and 4 goes into 28 7 times. So the ratio of boys to girls is either, we could write it as 32 to 28, or we could write it as 8 to 7, because those are equivalent ratios. Okay, the last one, and this one looks so similar to a problem that was on STAR a few years ago, so this is a really good problem. Ginger mixed 4 gallons of blue paint with every 7 gallons of yellow paint in order to make a shade of green paint. Which ratio of gallons of blue paint to gallons of yellow paint will make the same shade of green? So blue to yellow was 4 to 7. We're looking for one that is equivalent to that. Remember that ratios can be simplified, and any ratio that's equivalent will simplify to the same thing. And so we can look at all of our answer choices and see if they can be simplified. If they can, and they simplify to 4 over 7, then they're our answer. If they don't, then they are not our answer. 4 and 8 are both divisible by 4. So we get the ratio 1 to 2, which is not the same as 4 to 7. So we know A is not our answer. 10 to 12, both of those are even, so they're divisible by 2. And we get the ratio 5 to 6, which is not the same as 4 to 7. 20 and 35 are both divisible by 5. 5 goes into 20 4 times, and 5 goes into 35 7 times. So that is what we were looking for. But let's just look at D really quick to make sure. 16 to 21. I can divide 16 by 16 or by 8 or by 4 or by 2, but none of those go into 21. And I can divide 21 by 3 and 7 and 21, but none of those go into 16. So that's already in simplest form, and it is not 4 to 7, so we know that that's not equivalent. So the only one that came out equivalent was answer choice C. Okay, make sure you have that filled out, and if you need to rewatch the video because you're not so sure about it, you can do that, and then go ahead and work on your assignment for today.